Hello everyone, this is Zaki from iconviz.com. In today's tutorial, I will focus on two topics when generating dynamic facade in Revit. The first topic is to be able to construct different 2D patterns with different themes, as you can see here. This way is accomplished by using a simple technique of creating an organized network of lines inside the curtain panel pattern-based family. And here I'm showing a different of examples of panel styles: an Islamic, a contemporary, and a curved 2D pattern. At the same time, I will explore how to include parametric controls for the geometry. So for example, in this panel here, as you can see, you can go to the create and you can include some of the parameters which actually deals with changing the different sizes. So if I change this to 0.2 and I hit apply, it's going to become bigger and so on. The second part of this tutorial is to really demonstrate how to articulate the parameters of the facade panels using different logic. And in this way, we can utilize the Dynamo simple script to produce variety of panels and configurations. And I will dig into the details of this simple Dynamo script in the second part of this topic. And so at the end, we will have some fun with applying different panels and different divided surfaces. And you can see that the combination of how you design each panel and the shape and the geometry of each one will actually be producing a different effect. So this combination of geometry, parametric controls, and how you change the size of some of the panels. If, for example, I make this 1 foot here, you can see it start closing and opening, and that kind of thing can be done in a variety of thicknesses and dimensions. But it would be nice as a tool to aid the designers to create different configurations. All right, so let's get started. So the first thing we want to do is to start utilizing the curtain panel pattern family template. New file here and select new family. And for that, we're going to choose the curtain panel pattern base. I'm going to switch to the floor plan here just to show you the whole concept here. Basically, we want to create a different line works here, which create a network of lines, and then we can stitch and create sweeps along these lines. And so by adding a number of points and lines with reference lines, then we can create this web, which become the skeleton or the structure for the forms or the shapes of the pattern. All right, I'm just going to place the points in the middle here. And you can see in Revit, whenever you add a point like that, it has a surface normal or a normal curve value between 0 to 1. So if I make this 0.75, then it's going to move to 0.75 distance, meaning that from here to here, this is a distance of value from 0 to 1, and this point is at 0.75. I'm going to bring it back to 0.5, and I will continue adding some points here. Let's make this point at 0.375. Same thing, this one would be at 0.375. And the two opposite points also will be at 0.625. And in the same manner, I'm going to create same points on the opposite side over here. Let me go here. And let's put these points at 0.375. Everything is symmetrical. I'm creating here the Islamic pattern. So that's why the positioning of these points is corresponding with the geometry of the Islamic pattern. One of the other ways of continuing doing these placement of points, you can create a reference line, make sure it says 3D snapping, and in this instance I'm not gonna create a chain. I'm just gonna create lines like that, and then hit escape, and then continue creating lines like this. So you can see that I'm starting to create this organized web. In fact, I can go ahead and add a line, another reference line from here. And so what I want to do is to really adjust these values, these points, to be at 0.795, and the two opposite points here will be at 0.205. And so I've continued to create these network of lines and points. One thing important to point out is to every time you're creating these additional lines, you want to double check that this network is staying without any corruptions. So for example, when I change the size of this curtain panels unit size, you can see that all the lines have flexed and stretched in a uniform way. No lines have been deleted, no points have been removed, or anything like that. So far, this is the base network to start creating our diagrammatic 2D shape. So the next thing to do is to really start creating a secondary layer of reference lines, and this time we want to include the option of chain, because we want to create a continuous segments of reference lines. So I'm going to snap to this point and then continue going over here with this intersection, and then continue snapping to this intersection here and here and so on. We'll do that until we create one of the strips for this Islamic kind of Middle Eastern pattern, and then hit escape twice, escape. So as you can see, I created this kind of structure, 1, 2, that's going to be the first shape, and if the user continues creating the same network of secondary reference lines rotated at 90 degrees and 45 degrees, then you get the full picture of this Islamic pattern. Alright, so to continue from this exercise, let me close this. This is a ready-made example. So the next part of this curtain panel pattern is to show you how I've generated these forms. So to give you an idea, if I go ahead and select this form over here, and I'm going to delete it. After the user is happy with this configuration of this network of lines, you can add a point somewhere along here, and then set or show the reference plane, and go to set, and we're going to set this vertical plane as the current working plane. And you can add a circle or whatever the shape of this profile. Let's create a starting circle shape like this. So I'm going to choose this circle, and then the series of lines, I'm going to pressing Control to multiple select. Just want to show you what will happen if I choose those two and create a form. This is the shape that's going to get generated. Instead, let me repeat that and pick these series of reference lines, gonna have to be careful so that I don't pick two lines on top of each other or any reference line that are count out of context. And then let's hit create form. Now obviously there is this circle over here, so if I choose this form again and hit edit profile, we can make this profile parametric. We can create a diameter. And choose this dimension and add the parameters to it. Let's call it R, and make it an instance. And then finish. So to test the radius, we can make this 0.5, 0.5, apply. And so the radius of this swept circle will become bigger. So what I want to show you now is that the same principle would apply to the other patterns. So especially this one over here. Let's take a look at its construction. This one is very simple. So let me go ahead and hide these forms or the swept shapes. Hide element. And all that I have here is a couple of profiles, and they're kind of offset from the edge by a certain point. So this profile is set based on the positioning of this point. Wherever this point goes, the profile will go with it. So the user can feel free to create any specific distance. And let me undo that. So if I delete this form over here, and then I choose this starting profile, which is hosted to this point, and then this profile as well, and this. So I'm really selecting these multiple profile families, and I'll speak about this in a while. We will get this form created. Now, in this example, I selected to make this profile an external family. Sometimes the shape of the swept form is more than just a circle. So what I want to show you that this is a massing family, and it's really a 2D line work. It's nothing complicated. All that it has is a diamond shape lines, and they're hosted to these reference planes. So basically it has a length. You can make this 2 feet. You can make this 2 feet. And you can create a variety of sizes. So this massing family that is composed of just a number of lines is loaded inside the what we call the eyebrow shape, which was here. Yeah. And then in the same way, the user will add a point somewhere along a reference plane and makes this the hosting reference point, and then you just drag and drop the profile to be hosted here. Make sure that you really host to that point where you see this circle. That means your profile is hosted here. So this profile become attached to the location of this point. And so what I want to show you here is the parametric behavior of this panel, and it's basically, I called it an eyebrows because you can change this size. So if I change x1 parameter, you can see how it opens and closes. Just make it 0.5, that's better. At the same time, you see how these profiles, which is a mass family, I've attached the length and width parameter of the profile family to x2 parameter within this curtain panel pattern base family. Okay, so let's play with it. So if we change x2 and we make it 1, then this thickness is going to be different, and the knot width, let's make it 0.3, and that's going to make it much bigger. And so I'm just here showing a variety of examples of how to make these patterns. Feel free to download it from my website iconviz.com. And so at the end, to explore different design configurations, the users can make a number of curtain panels, and then for the sake of demonstration, we can assign any of these rectangular base curtain panel families. Let's try the eyebrow over here, and you can see the effect that it's giving if I select one of them and then right click and select all instances in the entire project. I just want to show you the behavior. If I change this to 1, then all of them will become like this, and we can change x2 to make it to 4 inches, for example. So the last thing that I want to show in this first part is really how users can now create different effects by applying the different panels over here. And sometimes Revit takes time to, well, that was really quick, but sometimes applying the panels to some surfaces can take a few time or a few seconds. I think it's reacting well. Remember also that these curtain panel families were kind of designed using the curtain panel pattern base component, which pretty much works whenever you have a one direction surface. And so here, let's try and zoom into this shape here or surface and assign the eyebrow panel over here. Users can also rotate the positioning of this pattern. You can make this 90 degrees if you want to create a different formation. But of course the result will be different. You can see this looks in a different way. Perhaps I can make this 12, so I'll make this 16 by 12. And so that's going to give us a different result. So now I really want to jump on to the second part of my tutorial here, which is how to create a simple Dynamo definition. And so the first method of altering these panels is using a simple formula. So basically in Dynamo you can utilize the select divided surface families. I think it's very useful feature which allows you to reduce a lot of amount of coding and scripting to just go ahead and you select this surface, and Dynamo is going to count the number of elements or panels within this surface. And really this part here allows us to specify in a string block the parameter that we want to change, and we can set the parameter string x1, which is basically this panel here. We can change x1 to 6 inches. That's what we want to control. And this is a simple example of how you can interactively change all of the panels using a math random number by adding a slider for value 1 and value 2, and then Dynamo is going to generate a math random number, and we're going to connect the number value to connect it here. Currently I'm not running this Dynamo script in an automatic way. It's set to be manual, so I'm just going to hit run. So you see all the values have changed here. And By changing this script to automatic, the user can interactively change the slider, make it shorter, smaller, so you can see the porosity and the intensity of the parameters are increasing, and these are just random values. Now I'm just going to switch it to manual. If I also assign this the bow tie panel here, one thing to remember is that I think you will need to reselect the surface again, and we can hit run. We can switch it to manual, or sorry, automatic, and we can play with changing the value of x1 and x1 also. Here we can make it like that. If I want to keep the value of x1 really small, it can give us more openness, and then I can change this to be x2, and I hit enter, and you will see instantly that x2 is going to be the opposite bow tie. Now we can change this to a different size. Okay, well, the second method really relies upon adding a more advanced logic for the value to set the parameters x1 and x2. And in this way, we are creating a list of values randomly, which will actually apply to the final value of the parametric panel. And as you can see, I'm defining that there is a range over here for the number, and here I'm specifying a fixed number, which is 48. Remember that this divided surface is made up of 7 by 7 values, or U and V grid values. So we have to specify, instead of 49, we have to specify 48 number of type of count for the panels. Alright, well, to continue with that, I'm bringing in the list of numbers over here, and I'm creating a kind of a formula whereby the list generated is giving a number over here for my list. Okay, well, to continue this and just show you what's this logic of formula is doing, let me just pin these numbers over here. So as the user changes these values here, the random 49 values will be generated. You can see how it's dividing and changing. We can change any amount of the number in the slider here. Also, you are specifying a minimum and maximum values here. We can make this 0.3, and this is 0.3, and this is 0.9, and you can run, and that's going to give you quite random values here. Now the next step is to really connect the resulting flattened values over here. I'm going to connect it over here. That's purely random. You can see that this is going to affect x2 parameter. So just to let you know that it took about 5 seconds to run this. Alright, so you can see the effect here. I'm going to isolate this element or the surface so you can see the randomness that it got generated. And just another trial over here. Let's make this 1.5 and really bump this up. And this time we want to change this value for x1 parameter and hit run. And there you go. You see the result here, variety. The third method of controlling these panels is by utilizing an analytical image, bitmap image, and I call it analytical because it can be the result of a solar exposure analysis, or the result of any analytical analysis like visibility from one point to another point on the facade. So basically, one of the improvements in Dynamo is that again, instead of spending a lot of time coding this logic between selecting an image and obtaining its pixels and brightness, by running a simple code of these blocks, the user can browse to the certain folder and pick an image that has a 7 by 7 pixels, because that's how our divided surface here is using. So just let me isolate this, and then reading the image information. Dynamo will obtain the dimensions, which is the size of the pixel. You can see, or the image, it's 7 by 7 pixels. And there's a quick demo or viewer of the image. At the end, we're kind of obtaining the brightness of each pixel. So each color point within the image pixels, it has certain brightness. The user can then obtain these brightness values and attach to it a kind of number over here and play with the values over here. The result of multiplying the first value, which is a user specific value, and the second value, which is the brightness, will create this effect of mapping the pixel shapes on the divided surface panels. And this is what we mean by articulating and dynamically configuring the facade panels. Again, this image can be an aesthetic image. It can be a designer vision of creating an effect on the facade. All right, so in this case, we're going to connect this over here. And I just want to reselect the divided surface panels over here. And let's hit run. All right, that wasn't too slow. Took a couple of seconds, and you can see here the effect is now happening, just pretty much similar to the shading gradient in that image. So it's up to the user to create this combination that gives you the best effect on the facade. You can use the combination of parameters built in the curtain panel and the image gradient on a 7 by 7. So that's not going to give us the variety of the patterning. So let's choose this again and rerun. Yeah, that makes more sense. You can see it here.